Hi there. Today we're going over section 5.7, solving radical equations. In this video, we'll talk a little bit about the process and then we'll do problem number 1 through problem number 5. Notice the squaring property of equality. If a equals b, then you can square both sides. You can also raise it to any power. What are some opposite operations that will undo each other when trying to solve an equation? Multiplying and dividing, adding and subtracting, squaring, and taking the square root. So if you have something raised to the fifth, how do you undo that? You take the fifth root. Here's a little process for solving an equation with radicals. First, get that root alone. Isolate the radical. Then you raise both sides to whatever that power is of the radical. So if it's a square root, raise both sides to the second power. If it's a fifth root, raise both sides to the fifth power. And then you solve, doing and undoing, multiply, divide, add, subtract, combine like terms, trying to solve for your variable. And then you check the solution in the original equation. Be careful when you have a fourth root. Sometimes you get a solution that is not true in the original. When you have a square root, anytime you have an even root, because sometimes when we solve, we find a number that won't hold true in the beginning. Remember, you can't take the square root of -2 or -5 or negative anything. That's just an imaginary number. And so trying to solve in the set of reals and then mixing in even roots kind of throws in some imaginary stuff, and you have to be very careful to not have extraneous solutions. So just check that out. Once you find the solution, plug it back in the original, make sure it makes sense and that it's true, and then you're good to go. All right, let's look at number 1. What do I do first? Isolate the radical. It's already by itself. Woohoo! How do I undo the square root? I square both sides. In parentheses, square both sides. This will give me 5x plus 1, since the square and the square root undo each other, and then 4 squared is 16. Now I continue by subtracting and dividing to solve for x. So subtract 1, so 5x is 15, divide, so x is 3. Then I check. If I plug in 3, 15 plus 1 is 16, the square root is 4. It holds true, so the solution is x equals 3. Let's look at problem number 2. Isolate the radical. Check. Undo whatever the root is. So this is a square root, so square both sides. Notice x plus 1 quantity squared is a binomial that you have to multiply. X plus 1 times x plus 1. This is not x squared plus 1 squared. You cannot distribute if you're adding in the middle. Okay, so make sure you remember, distribute the x to both pieces, then distribute the 1 to both pieces. You cannot say x squared plus 1 squared. That's not true. Okay. All right, so I squared the left side to get 5 minus x, the squared, undid the square root. And over on the right side, I have a little bit of distributing work to do. So 5 minus x equals x squared plus x plus x. So the middle terms add to 2x, and then plus 1 times 1, which is 1. Now combine like terms by moving this over. So I add the x to both sides. On the left side, I'll get 0, and then I subtract 5 from both sides. So I zero out the left side. And since the property of equality, I could just say x squared plus 3x minus 4 equals 0. So notice I just combined those like terms. Now, how do you solve a trinomial? By factoring. Two numbers that multiply to give you -4 and add to give you 3. If you're multiplying to get a negative, you need one of each sign. And 4 times 1. So 4 minus 1 is 3, and 4 times a negative 1 is negative 4. Now I see that x will equal negative 4 or 1. Don't forget to go all the way. What are the x values that make this equal to 0, that make that statement true? My answer is not 4 and 1, not 4 or negative 1. It's negative 4 and positive 1. Make sure you have the correct answer. Now, am I done? Put a box on it? No, you have to check it first. Okay, so when I come over here to check it, I can plug in negative 4 and see if it's true. 5 minus a negative 4 would be 5 plus 4, which is 9. The square root of 9 is 3. And on the right side, negative 4 plus 1 would be negative. Uh-oh, dun, dun, dun. This is called an extraneous solution. Let's test 1. 5 minus 1 is 4. The square root of 4 is 2. 1 plus 1 is 2. Yes! So be careful, especially when you're taking even roots. X equals 1 is our only true solution. Let's look at number 3. What do I do here? First, isolate the radical, so subtract 2 from both sides, and I have the square root of 5x plus 3 is equal to negative 2. Then I square both sides. So put it in parentheses and square both sides to get 5x plus 3 is equal to 4. Then I subtract the 3, so 5x is equal to 1, and divide by 5. X is 1/5. Should I put a box around it? I don't know. Let's check. If I plug in 1/5 and divide first, that just gives me 1, plus 3 is 4. And so the square root of 4 is 2. So 2 plus 2 is 0. No, this is an extraneous solution. So your answer is no solution. Let's look at number 4. First of all, isolate the radical. So I need to divide both sides by that 2. So I just have the cube root of 1 minus x alone, and on the right side, 4 divided by 2 is 2. Now, how do I undo the cube root? I cube both sides. So raise both sides to the third power. The cube root and the cube undo each other, and I'm left with 1 minus x equals 2 cubed, which is 8. Then I just subtract the 1, so negative x equals 7, and then divide by negative. So x is negative 7. Should I box it? No. I need to plug it in and make sure it's true. Now, this is a cube root. It's odd. It'll probably work, but let's just check. 1 minus a negative 7 would be plus 7, so that would give me 8. The cube root of 8 is 2, and 2 times 2 is 4. Yes! So this is a true solution. Let's finish this video with problem number 5. Isolate the root. Done. Now raise both sides to the fourth power. So the fourth root and the fourth power undo each other. Remember, you're just dividing 4 divided by 4, which is 1. And t minus 10 equals 3 to the fourth power, which is 81. And then you add 10, so t equals 91. Should I just put a box? Probably because it's even, but let's test. I plug in 91, subtract 10, 81. The fourth root is 3. I'm set. I hope that helped clarify a few things. Keep up the good work. See you later.